All right, so I got a math problem for you. We're gonna add these numbers together. We got 4/5 plus 3/5. If I add it together, that's gonna give me what? Right, you got it? Okay, so I'm gonna add. By the way, what do I do? If the denominators are the same, what do I do with those denominators when I'm adding them? Do they change? Do I add them or do they stay the same? Do the number of pieces change? No. Right? Think about those dozen eggs, right? You always get eggs in a dozen, or maybe sometimes in a package of 6. But the same if you're getting the same kind of eggs, they're always in a package of 12, right? A dozen eggs, right? So that dozen doesn't change, right? Those pieces don't change, right? But the amount in them, the number of pieces of those, does change because we can manipulate or change those numbers. So here, those numbers don't stay, those pieces stay the same, but we're gonna add the numerators across so that 4 plus 3 gives us 7. Now in math, when the numerator is much larger than the denominator, we have something called an improper fraction. Now think of it, if you have a dozen eggs and someone gives you a dozen eggs, they give you a full carton of dozen eggs and they give you 2 more eggs on top of that. Is that weird? Wouldn't it be better to put those 2 eggs in another carton? We need to represent fractions in a way that's easier for us to understand, right? Because our denominator is greater than because our numerator is greater than our denominator, we want to change this in a way so we want to find out how many whole pieces there are. And now I'm going to teach you how we're going to do that. When we add 4/5 plus 3/5, that's the same as 7 of these fifths added together. 1, 2, 3, 4, 5, 6, and 7. Right? We're adding all those 1/5 squared. This is called repeated addition. All I did was I simply broke up that 4/5 into here. 1, 2, 3, 4. Right? There's 4 of these fifths. Right? And then we added the 3/5, which is these 3. Okay. Now, to get a whole number, how many total fifths do I need? To have a whole number, how many of these fifths need to go together? How many of these fifths do we need to put together to give us one whole number? So I'm going to pause the video and I want you to think. What am I going to do? Right? We're counting by fifths now. So remember when we counted by twelfths? And you had 12, and how many eggs are in a dozen? And how many eggs do we need to have a full carton of eggs? Well, now I want you to think, how about if something is broken into fifths? How many pieces do we need to have a full piece of fifths? Right. You ready? You got it? Well, let's go count. If there's 5 pieces, if they're broken into fifths, how many will we need? Well, it gives us the answer in our denominator. Our denominator tells us how many pieces make a whole number. So I got 1/5 here. I got 2/5, 3/5, 4/5, 5/5. So I have 5/5. Right? So our numerator and denominator, they're even pieces. So if I had a whole cake and I cut it up into 5 pieces, how much of a whole cake do I still have? Does it change? I mean, it may not look pretty, but it is the same whole piece. We're doing the same here. How many do we have left over? We have 2/5 left over. Okay? So all I've done is I've taken this apart, broken it apart, and I've broken this into a whole number. How many total pieces we have? And then how many do we have left over? Well, when the denominator and the numerator are the same, that's the same as having a whole. Just think about when you get a pizza. You have 8 slices or 16 slices maybe? I think it's 8 slices. You have 8 slices. That whole pizza is an even pie. That's a whole pie of pizza. The same thing here. We have 5/5. That's still one whole piece. So when the denominator and the numerator are the same, or the numerator and the denominator are the same, that's equal to 1. Now, we're just going to add the leftover piece here, which is 2/5. And we're going to put it together. And we have just completed a mixed number. So I'm going to give you some practice to work on for today. You don't have to do this. This is supplementary to help you with the Khan Academy. But I really would like for you to practice because we are going to do our math lesson on Friday. And if you're struggling a little bit, you might enjoy. All right, so that concludes our math lesson. I'll see you all Friday. Goodbye.